Well, let's take a look at our Keras data generator example. In that example, you remember that we had a convolutional neural network at here, but I want to use Keras image data generator function because I don't want to confuse you with the preparing the dataset part. Since we already prepared the dataset, we just can we should focus on only transfer learning. Well, I deleted the convolutional neural network part since we will apply convolutional neural network that is trained on ImageNet dataset. And also I want to check the documentation of Keras. And in this application documentation, well, this is very important to apply transfer learning because in Keras transfer learning or fine tuning is very easy to apply. So you just need to check and design a few lines of code, and you should edit just few lines of code, and then you will have transfer learning and have an algorithm that works properly. Well, if you remember in our uh, slides we have ImageNet results, and in that we see that inception v3 and inception v4 has the highest accuracy. So I think that we can take these uh, algorithms, take these architectures, we can apply one of these in our project uh, with respect to transfer learning. So let's take the inception v3 and check the input of it. Well, you see that the default input size for this model is 299 to 299. So according to that, in our codes, well, we should change the target size so that we can properly work with our data and we can adjust our data according to our architecture. Well, then we should apply convolutional neural network. But before going into application, I want to talk about the transfer learning again, and I want to give a detail about it. Well, in our slides, I added the two new pages. Well, in transfer learning, now let's check the left side. Well, we have the data. We have data that is related to our data, or that is not related, but very large data. I mean, for example, in ImageNet, we have a general data, and also it's really large. And let's say that we have successful convolutional neural network architecture and have a good accuracy on that. So why don't we apply the same convolutional neural network architecture with the same parameters and with the same weights? Well, let's take the inception v3 and apply it to our cat classification, and then let's see the results of it. But it's not guaranteed to get a good results, but mostly we will get a good accuracy in a short amount of time. Also, it is said that when you apply transfer learning and apply it to other datasets, it's actually have an effect of data augmentation. It means that your data is like, uh, let's say you have 100 images per class, but if you use transfer learning and if you use the transfer learning and get the weights of successful CN architecture, it will become like you have 3,000 images per class. I know it's not a true thing, it's not a theoretical. I just say it because that transfer learning has an of effect like enriching the data. So it increased the accuracy. Transfer learning increased the accuracy, and some says that it is due to enriching data effect. Well, and after that, let's see how we will apply transfer learning with the techniques of convolutional neural network. So in technical details, there are right sides of our convolutional neural network, and the name of it is top of the CNN. Well, in top of the CNN, you have the fully connected network, and you see 1000 number here. And as you remember, in ImageNet challenge, we have 1000 classes and 1000 categories. But to apply transfer learning, we say that we need to take the filters of it. So this is the part that we will take. So we don't need it, and also it is designed for ImageNet dataset, or it is designed for a dataset that contains 1,000 categories, but we have only 2 categories to classify. So we don't take here, we don't take the top of it. So we don't include the top of our convolutional neural network, and we will only take the convolutional layer part. And after taking this, we will write our own top of convolutional neural network. And in our convolutional neural network, the last layer will have 2 hidden nodes, since we have 2 categories, and we will freeze the majority of convolutional layers starting from beginning, since the weights are trained on ImageNet dataset and has a good accuracy. We just can freeze these layers. What is the meaning of freezing? When backpropagation, you won't get these weights changed. So these weights will be the same, but in backpropagation you update these weights. But if you freeze these layers, you actually have the same weights, so it won't affected by the backpropagation. These values will be the same in every iteration and also in every epoch. And also the thing that we should also do is, and I scribbled out the slide, but choose a small learning rate. This is also essential for our, let's say that it can be like that, but you should try it. And this is essential for our applications, our transfer learning applications. So let's do it.